Hi, my name is Devin Brown, and today I'll be talking about NoSQL, and this is for SCR 322 Spring A 2017. So what is NoSQL? NoSQL is an acronym that stands for Not Only SQL. NoSQL is an approach to databases that represent a shift away from traditional relational database management systems. Traditionally, relational databases rely on tables, columns, rows, or schemas to organize and retrieve data. On the other hand, NoSQL databases do not rely on these structures and use data models that are much more flexible. NoSQL became very popular because of its scalability that is needed in today's software industry. Relational databases have failed to meet the performance, scalability, and flexibility that is needed in order to run today's applications. History of NoSQL. Non-relational database systems have been around for quite some time, since the late 1960s. The name NoSQL was first used in 1998 by Carlo Strozzi as the name of a file-based database that he was developing. The term went dormant for quite some time and then picked up traction again around 2009 when a man named Eric Evans used it to name the surge in non-relational databases. So why would one choose to use NoSQL? Developers in today's world are working with applications that create massive volumes of new, rapidly changing data types, structured, semi-structured, unstructured, polymorphic, among others. There's an increasing need to have more flexibility with your database in order to meet the current landscape of where the software industry is going. In a lot of projects, code is pushed out very quickly and iterations occur often. Relational databases were not designed to cope with the scale and the agility challenges that face today's modern applications. What are the benefits of using NoSQL? NoSQL is more scalable and provides superior performance in many instances for today's projects. NoSQL addresses several issues that the relational model is not designed to address, such as large volumes of various types of data, agile sprints, quick schema iteration, and frequent code pushes. NoSQL also makes use of object-oriented programming that is easy and flexible to use. Some of the high points of NoSQL is flexible data modeling as well as high availability. When we talk about flexible data modeling, NoSQL offers the ability to implement flexible and fluid data models. Application developers can leverage the data types and query options that are the most natural to fit the specific needs of their applications, rather than try to fit those within a database schema. The result is a simpler interaction between the application and the database, which is generally more faster, especially within agile development. When we talk about high availability, NoSQL databases are generally designed to ensure that they are highly available and avoid complexity that comes with the typical relational model. Some NoSQL databases use a masterless architecture that automatically distributes data equally among multiple resources so that the application remains available for both read and write operations even when one node fails. Here are some major problems that NoSQL addresses. SQL was designed to be a single node system and was not designed to be used with large clusters. NoSQL allows you to store complex data types over a large number of clusters very efficiently. The need for a database system to be used over a large set of clusters has been increasing as the technologies have evolved. In a lot of cases, SQL was just not working to be very flexible, and it didn't allow for a lot of fluidity throughout a project. That's part of the reason why NoSQL has become very popular, is because you can set it up very quickly and use any type of data out there in your database. Now I'm going to introduce some of those popular ways to model data within the NoSQL family. The first being a key value pair. A key value pair is a type of aggregate-oriented structure that allows you to go to one node on that structure in order to grab all the information you need. In a traditional relational type system, you would have various tables that have bits and pieces of all the information that you need, in which you would have to incorporate various joins to get all of that information in one query. The upside to having an aggregate-oriented structure is having all that information in one place, which makes it great for storing data on large clusters. A key value pair is a set of two linked data items. The first being a key, which is a unique identifier for some item of data, and the value, which is either the data that it identifies or a pointer to the location of that data. In a NoSQL environment, the database knows nothing about the value, nor does it care. It allows you to store complex data items such as a JSON object that can have many different key value pairs in it itself. Another popular way to model data is a document structure. A document structure doesn't follow the traditional table or row model that many are used to. It stores relevant data together in a single document. In a lot of ways that data is represented is in a JSON object where you can have maybe an ID field, a name field, or any number of fields. You can even have a JSON object which has a JSON array which has many different keys and values for each data item that you need to represent. And again, a document structure holds those complex types, which allows for a large scale of flexibility within your database. Now, a third way to model data is a graph-like structure. The previous two data modeling types were aggregate structures, but the graph type is not. The graph type has connected entities which are represented as nodes that can hold any number of attributes such as a key value pair, JSON object, whatever it may be. These nodes can be tagged with labels which represent the different roles in the domain. Those labels can also hold metadata. Two nodes can share any number or type of relationships without sacrificing performance. So any node has that relation to various other nodes, and then you can traverse this graph in order to grab all the data you need. And with these three major types of modeling data, there's going to be give and take with each type. So it is important to look at your project and what you actually want the architecture to be in order to make your system the most efficient. And here's a graphical representation of how you would choose to pick which NoSQL database you would want to use. As you can see, there are three primary concerns you must balance when choosing a database management system: consistency, availability, and partition tolerance. Consistency means that each client always has the same view of the data. Availability means that all clients can always read and write. Partition tolerance means that the system works well across physical network partitions. One of the primary goals of NoSQL systems is to bolster horizontal scalability. To scale horizontally, you need strong network partition tolerance, which requires you to give up either consistency or availability. NoSQL systems typically accomplish this by relaxing relational abilities and or loosening transactional semantics. So again, it goes back to there's going to be a give and take with each type of database you choose to go with. If you decide to go with a NoSQL type database, then you have to choose which type of way to model your data, as we just talked about, as the document model or the key value or a graph type structure. And there's going to be those ups and downs with each type of database that you choose, so you really have to look at that architecture of your system in order to decide what is best for you. Ever since NoSQL has gained popularity, there has been an age-old question of SQL versus NoSQL and which way is better. Now here are some points for and against both SQL and NoSQL. In SQL, the databases provide a store of related data tables. The design is very rigid. You cannot use the same table to store different information or insert a string where a number is expected. It makes use of schemas, which include primary keys, indexes, relationships, etc. And generally, a SQL-based system has normalized tables. And with a design being very rigid in a SQL-based environment, it goes back to the schema being very tight, and you can't move away from the schema, and you have to fit your system to within what the schema identifies. In a NoSQL environment, they can hold complex data types, which allows for a lot of flexibility and fluidity throughout your program. It's schemaless, so there's no kind of blueprint for your database that you have to follow. There is no equivalent to a SQL join in NoSQL, and denormalization is common in NoSQL because having all of that data available at the node that you're querying makes it much faster in that sense. In SQL databases, 2 or more updates can be executed in a transaction, an all-or-nothing wrapper that guarantees success or failure. SQL is also a lightweight declarative language. In a NoSQL database, modification of a single document is atomic. NoSQL databases use JavaScript-like queries with JSON-like arguments. Basic operations are simple, but nested JSON can become increasingly convoluted for more complex queries. For example, imagine you have a bookstore table and a stock table. When a book is ordered, we add a record to the order table and decrement the stock count in the stock table. If we execute those 2 updates individually, one could succeed and the other fail, thus leaving our figures out of sync. Placing the same updates within a transaction ensures either both succeed or both fail. In other words, if you're updating 3 values within a document, either all 3 are updated successfully or it remains unchanged. It's deceptively powerful and has become an international standard, although most systems implement different syntaxes subtly. Perhaps the most controversial comparison is that NoSQL is regularly quoted as being faster than SQL. This isn't surprising. NoSQL's simpler denormalized store allows you to retrieve all information about a specific item in a single request. There's no need for related joins or complex SQL queries. That said, your project design and data requirements will have the most impact. A well-designed SQL database will almost certainly perform better than a badly designed NoSQL equivalent and vice versa. So here are some examples of projects where SQL is ideal. Logical related discrete data requirements which can be identified upfront. Data integrity is essential, standards-based proven technology with a good developer experience and support. And an example where NoSQL is ideal. Unrelated, indeterminate, or evolving data requirements, simpler or looser project objectives, and able to start coding immediately. Speed and scalability is imperative. So here are some examples of popular NoSQL databases. You have the 4 major types of NoSQL databases, which is graph database, key value database, column database, and document database. Each of these databases are going to have their advantages, and it really is up to your system architecture to determine which type is best for your project. Here are some examples of popular websites and the database systems that they use. The king of scalability, Google, uses Bigtable. Facebook uses Hive and Cassandra. Yahoo uses modified Protege SQL. YouTube uses MySQL, but they are moving to Google's Bigtable. MySpace uses SQL Server. Twitter and Wikipedia use MySQL. Microsoft uses SQL Server. And Flickr uses MySQL. And again, all these websites, these aren't the only types of databases they use, but they use a combination of NoSQL databases as well as SQL databases that serve different purposes within their websites. Here's an example of a popular web stack called the MEAN stack. MEAN is an acronym that stands for MongoDB, Express, AngularJS, and Node.js. MongoDB is the database system, which is a document-based database. Express is your back-end web framework. AngularJS is your front-end framework, and Node.js as your backend runtime environment. This is a very popular implementation of a NoSQL database within a framework that powers many websites across the web. Here are some references that were used throughout this presentation, and I'd like to thank you for listening.